The infamous word problems. Guess what? We did word problems last week. We're going to do them this week too. They're that important. I mean, really, we do all this kind of practice work so that when we get to these word problems, we're able to know how to solve it out. But the first step you got to do with some of these word problems is you got to pull out the important information and create an equation. So I'm gonna walk through and show you how to do this. Okay. Now, these word problems, I can tell you, because we're working on system of equations, all of them are going to result in two equations. So on all of these, you're going to have two equations. So the key is to match up the information that goes together, things that are kind of similar. I do that with my son. He's just 3 years old, but we talk about like similar things. So that's kind of what you're going to do here, but in a little more complex way. So whenever I'm creating my equations, I'm going to pull out information, and you're going to notice that there's some things that they have in common. The first equation, something that all of those facts are going to have in common is they're all going to be talking about money. The second equation, you're going to realize that they all have something in common too. They're all talking about number of people. So whenever you're looking through here and pulling out information, you can say, all right, so these things they're all talking about money, so I'm going to put them in my money equation. And all these other things are talking about number of people, I'm going to put them in my number of people equation. All right, so let's get at it. The only way to really understand this is practice. So the admission fee at a small fair is $1.50 for children. That's talking about money. $1.50 per child. So we have $1.50 for each child is how much we're going to bring in. Also, $4 for adults. So we have $4 for each adult. I'm going to use A for adult ticket, okay? On a certain day, 2,200 people entered the fair. That's not talking about money. That's talking about how many people. So we're going to skip past that. And $5,050 is collected. So my money is going to total $5,050. So now you're like, well, do I add these or do I subtract them? And so the way you think about it is because it's a real life situation, you're like, well, does it make sense for me to charge all this money for the children and then I'm going to subtract the money for the adults and that's going to bring me to $5,000? No, not really. It doesn't say I'm paying adults to come here. So it does make more sense that I would be adding these two, because however much money I bring in for the children, and then I'm going to bring in money for all the adults, and together that's going to give me $5,000. Okay, so that makes more sense for us to add these two. So now let's look at the information that talks about number of people. So only thing I'm reading here is on a certain day that 2,200 people enter the fair. So I know that it's going to result in 2,200 people are there. So then you're like, well, how do I know what to put over here? So you got to use critical thinking skills here, because you're saying, well, wait a second. Who's in this fair? Okay? All right. People are in this fair. Well, what kind of people are there? Well, there's only two types of people that they're telling us about. The number of children plus the number of adults are going to equal all 2,200 people. Okay? So I'm not like adding in dogs. I'm not like saying plus dogs plus giraffes. Okay? No, that doesn't make sense. They're not telling us. In fact, right here you can see that they say 2,200 people. Okay? So there's only children there and adults there. That makes up everyone. It's going to equal 2,200 people. Okay? So now you can solve this any route that you want, now that you have your two equations. But you have to have these equations in order to be able to solve it. So what I'm going to do is I'm going to use, I guess I'll use substitution. Like I said, it doesn't matter. So I'm going to get a variable by itself. So I'll get C by itself. So I'm going to subtract an A from both sides. And that's going to result in C equals a negative A plus 2,200. So now what I'm going to do is, I know that C equals all this stuff. So I'm going to take all that stuff and I'm going to sub it in for C. And whenever I do that, my equation looks like this. 1.5 times, I'll leave some space to write all that stuff, plus 4a equals $5,050. All right, equals $5,050, and so now I'm going to plug in negative a plus 2200. I'm going to use a distribution property here. 1.5 times a negative a is a negative 1.5a, and 1.5 times 2,200. Let's see. You can use a calculator, but I've already done it. Let's see. It's going to equal a positive 3,300. 3,300. You can check my math on that. Plus 4a equals 5,050. Now I'm going to combine like terms. Combine that negative 1.5a and a positive 4a. Whenever you do that, you might have to review how you subtract with decimals, but you're going to end up with 2.5a plus 3,300 equals 5,050. I'm going to subtract this side by 3,300, subtract this side by 3,300. You're going to end up with 2.5a equals 1,750, 1,750. And then I'm going to divide the left side by 2.5, divide the right side by 2.5, and I am left with a equals, you would have to divide that out, but you're going to find out that a equals 700. So now what you're going to do with this information is, you know, a equals 700, you're going to plug that in for a, and then find out what c equals. So whenever I do that, my equation looks like this. I've got c equals a negative, and I'm going to plug in my 700 because that's what a equals, plus 2,200. 2,200. And it doesn't matter which equation you use. I'm just using this one because it looks easiest. So now what I'm going to do is I'm going to take a negative 700 and a positive 2,200. Whenever I combine those, I end up with c equals 1,500 because I subtract because my signs are different. And I have more positives, so that's why it's a positive answer. So here we go. There's my answer. Number of children, there was 1,500 children there. Number of adults, there were 700 adults there.